Good afternoon. In this session, I'm going to demonstrate how Juniper data center switches work with VMware NSX multi-hypervisor controller to provide a comprehensive network virtualization solution. There are multiple Juniper products support VXLAN and can be integrated with NSX controller. In previous session, I already gave a brief overview of NSX and demonstrate how Juniper QFX5100 works with NSX as VXLAN Layer 2 gateway. Today, I will focus on MX and EX9200 switches to demonstrate their Inter-VXLAN Layer 3 gateway function, enable the communication between virtual and physical without VXLAN or VLAN boundary. So let's look at the demo topology. We already virtualized most part of a data center. For example, we have the virtual machines running on Ubuntu KVM with OVS, but there are still some physical servers that need to be integrated. QFX5100 switch provide a VXLAN Layer 2 gateway function to bridge the physical to virtual communications within the same VXLAN or VLAN segment. So virtual machine S5v1 can talk to physical server 1 within the same subnet. This is one of the traffic patterns I demonstrated in the previous session. However, the communications between different VXLAN VLAN segments need to be enabled. So for example, server 1 and server 4 in different VXLAN segments need to talk to each other. And similarly, server 3 to virtual machine S5v1 also need to talk to each other across different VXLAN segments. The Juniper MX and EX9200 platform provides the Inter-VXLAN VLAN function to make that happen. So the key point for this demonstration is the virtual overlay network is provisioned by NSX via OVSDB. MX EX9200 is the Inter-VXLAN routing Layer 3 gateway. QFX5100 is a VXLAN Layer 2 gateway, and altogether they enable the communications between virtual and physical. Let's go to NSX Manager. In previous session, I already gave a brief overview of the NSX Manager and the NSX Controller, so I will just highlight what's the additional component I added for this demonstration. The transport component defines the physical component of the underlay network, so there are 4 gateways defined. So look at the gateways defined in the NSX controller. In addition to the 2 QFX5100 we defined last time, I added the EX9200 and an MX platform. The service node is used to handle the bomb traffic, and in the gateway service, in addition to the physical port for QFX5100, I also added the gateway service on EX platform and MX platforms. Then we move to the logical component. I defined 3 logical switch, logical switch 1, 2, and 3, so we can demonstrate the inter-VXLAN communications. I also defined 12 logical switch port. So those 12 logical switch port is being assigned to different logical switch. MX000 is a logical switch port attached to logical switch 3. It's corresponding to the gateway service port XE000 on the MX platform. We got all the green light, looks like we're ready to go. So let's check the actual configuration on each gateway service. First, we take a look at the configuration on the MX. So we defined 3 VNI, VNI 100, VNI 200, VNI 300. So this is all the configuration we needed to make the MX as a default gateway for a VXLAN segment and make the Inter-VXLAN working on MX. For example, here we defined the VXLAN UUID with VNI 300. It's being managed by OSDB. And similar, we define VNI 200 and VNI 100. We define the interface managed by OVSDB, and also we define the IRB interface used as a default gateway for the VXLAN segment. And of course, we also need to define the OSDB controller address so MX can talk to the NSX controllers. This is all the necessary configuration you need to have. Then we look at the configuration on EX9200. So similarly, this is all the necessary configuration for the EX9200 to serve as a default gateway for the VXLAN segment and also to enable the Inter-VXLAN function on EX9200. So here I have some other configuration, for example, the VNI 20 and 30 used on the previous demonstration for the Inter-VXLAN routing with the support of IP multicast. So last we look at the configuration on the QFX 5100. The configuration is the same as last time since we didn't add any additional VXLAN functionalities. So similarly, this is the configuration on QFX 5100-2. So all the configurations, including the NSX configuration, looks great. Now we're ready to move the traffic. We're going to use the traffic generator to generate a full mesh bidirectional traffic. Using traffic generator allows us to configure more complex traffic patterns, launching all traffic streams simultaneously, and also check the traffic rate in real time. So we have 4 traffic ports to simulate 4 servers. Port 71 and 72 are for Inter-VXLAN traffic. As you can see, they are sit within the same IP subnet. Port 73 is attached to EX9200. It sits on the 192.85.20 IP subnet, and port 74 is attached to MX platform. It sits in the 192.85.30 subnet. So before we start the traffic, let's resolve the ARP first. We select all 4 ports and send the ARP request. On the bottom status bar, it shows the ARP is resolved. Let's take a look. All the ARP address has been resolved. So now we're ready to start the traffic. Let's go to the traffic stream. So in traffic stream, we already defined full mesh traffic patterns. So for example, on the first one, it's from the first port and going to port 2, 3, 4. And on the second port, the traffic starts from port 2 and goes to port 3, 4, and 1. The last traffic port is attached to MX, is sending traffic to VNI 300, is being Inter-VXLAN route to VNI 100 and 200 on port 1, 2, 3. Now we select all the traffic stream and start the traffic. So we configure each port to send 10,000 packets per second. As you can see, the traffic rate is 10,000 packets per second, and the received rate is also 10,000 packets per second. Now all data packets are sent and received successfully in a fully meshed traffic pattern for both Inter-VXLAN and Inter-VXLAN. While the traffic is running, let's go back to the test setup to use a few show commands to check the status and look at the traffic counters. So this is the QFX 5100 where we stopped when we show in the configuration. We can use show OVS. We can use show OVSDB MAC to show all the MAC address learned by OVSDB protocol. We can also use monitor interface traffic to monitor the real-time traffic counters. As you can see, actually, the port 000 is attached to traffic generator. It roughly received and sent 10,000 packets per second. So similarly, we can use the show command to check the status on MX and look at the traffic counter as well. On MX or EX9200, that'd be more interesting because those 2 devices are doing the Inter-VXLAN routing. We should be able to see all the MAC address learned from different VNS. So as is showing here, for this logical switch, so this is the MAC address learned. This is the second logical switch. This is the third logical switch. All these MAC addresses from different logical switch are learned on the MX platforms. So similarly, on EX9200, we should be able to see all the MAC address learned on the different VXLAN segment as well. So this is all the MAC address learned on the EX9200, which is a layer 3 Inter-VXLAN gateway device. Now we go back to this MX platform. We can also use the monitor interface traffic command to look at the real-time traffic counters. Port 000 is roughly a 10,000 packet in and 10,000 packet out. As you can see, the counter update in the real time. Now just go back to review the topology again. So what we have demonstrated is a virtual overlay network. It's being provisioned by NSX and MX EX9200 perform the layer 3 Inter-VXLAN routing. QFX 5100 is a VXLAN layer 2 gateway, and altogether provide comprehensive network virtualization solutions without the boundary. So this concludes our demonstration. Thank you for your time.